Hello guys, once again you're welcome to Nissi Academia. If you've not subscribed to this channel, do well to subscribe. And of course, if you find this video beneficial, do well to share and like as well. If you have any question whatsoever, ask your questions in the comment box below. Alright, so basically we'll be looking at the 7103.2 is a 100 level course titled Basic Laboratory Techniques. All right, so in this course the main focus is biological techniques. All right, and these are 350 questions, which are of course from past questions and also frequently asked questions in the course, and everything that relates to the outline or scheme of the course. So Mr. K Academia have been able to put together 350 questions, and in this video we'll be doing justice to these questions. I'll be providing you with the answers and explanation to each of them. All right, so now the first question we have here is: a laboratory building should be sound with secured doors. The answer is doors. Number two, doors in a biological laboratory should be burglary proof and insect free. Number three, the diagnostics laboratory should have a sufficiently large working area and a dash. All right, it's supposed to be a dash there, and a dash for both patients and specimens. Okay, and a reception for both patients and specimens. All right, a reception for both patients and specimens. All right, so the next one is: separate area should be provided for cleaning and dash of materials. Okay, cleaning and decontamination of materials. All right, that is removing of contaminated materials, contaminated substances, contaminated samples from the laboratory. Number five, to avoid rust in pipes, taps in the laboratory should always be running. All right, running. So the taps should always be running. There shouldn't be any period where the taps should lack water. All right, there should always be steady water supply from the taps. All right, the next thing: black, blue, or red pen should be used in a laboratory because they cause improper, should not be used. Okay, the word is should not be used because they cause improper illumination of light. So those colors should not be used in the laboratory because of improper illumination of light. All right, so the recommended paint colors for laboratory walls are yellow or white. A typical biological laboratory has workbenches with sink, water faucets, and dash rack. The answer is reagent rack. All right. Now, special cabinets rather are used to store dash in the laboratory. They are used to store chemicals in the laboratory. Apart from workbenches, other important items in the laboratory include teacher's table, first aid kits, dash. That dash is called safety. All right, safety charts and fire extinguishers. All right, the safety chart which shows safety symbols and of course how to avoid those forms of danger signs, and also maintaining and facilitating safety in the laboratory. All right, so the next question here is: the quality of laboratory workbench top is crucial to withstand corrosive chemicals, light temperature, and wet conditions. The answer is wet conditions there. Now, MDF stands for medium density fiber board. All right, it's medium density fiber board. Now, MDF is denser and stronger than particle board, but has poor dash resistance. It has poor water resistance. Ply laminate board provides better resistance than MDF but has higher porosity. All right, it is more porous. All right, it is more porous than MDF, but it provides better resistance, okay, than MDF. That's one thing that distinguishes both of them. And number 15, granite is resistant to water but vulnerable to acids. All right, it resists water, but when it comes in contact with acids, it cannot resist it. All right, the next one is: the dulling of granite top surface due to acid reaction is called etching. All right, it's called etching, etching. Okay, so etching is known as the dulling of granite top surface, which is as a result of acid reaction. All right, so the next one is: phenolic boards are bonded with waterproof dash resin adhesive. All right, waterproof phenol resin adhesive. All right, so it is phenol. Phenol is more like a benzene derivative. All right, so that's why we have phenolic boards. All right, because they are bonded with waterproof phenol resin adhesive. All right, so the next question here is epoxy resin coating improves a workbench resistance to heat and scratches. So it facilitates the ability for workbenches to resist heat and scratches. The next question there is island workbenches can be accessed from that sides. They can be accessed from all sides. Now, an 8 by 4 island workbench can accommodate 6 to 8 students. All right, so that's the range of students that an 8 by 4 island workbench can accommodate. All right, so the next question there is the maximum temperature allowed in a laboratory is 20 degrees Celsius. That's the maximum temperature allowed in a laboratory. The next question, if laboratory temperature is low, heat can be provided by a central boiler. All right, by a central boiler, more like a boiler that can be able to go around the laboratory. That's why it's called central boiler. All right, so the next question there is if laboratory temperature is high, dash or air conditioners should be installed. All right, so windows or air conditioners should be installed. So normally there's supposed to be windows in the laboratory. All right, but more windows can be installed. All right, to ensure that the laboratory temperature increase is actually controlled. All right, number 24, natural light should be supplemented with artificial light. All right, in the laboratory. Now, the next one there, number 25. The type of tubes used for proper illumination in laboratories are large fluorescent tubes. They are called large fluorescent tubes. All right. The next question: all 40 equipment in the laboratory should not be used. All right. So any equipment that is faulty in the laboratory should not be used. Now, power sources should be switched dash before leaving the lab. It should be switched off before leaving the lab. So the lab is not supposed to be left with power sources on. All right. So once laboratory technologists or laboratory scientists are leaving the lab, they should ensure that all power sources are turned off and switched off. Now, gas in the laboratory is used for boiling solutions and flaming. All right, so it's actually used to either boil solutions or to produce flames. All right, most gases are flammable in nature. Now, laboratory glassware is commonly made of borosilicate or soda lime glass. All right, so those are the type of materials or types of glasses that are used to make laboratory glassware, or let me say commonly made of borosilicate or soda lime. So those are the common ones. Now, borosilicate glasses are resistant to mechanical shock, thermal shock, and of course, chemical radiation. All right, so the answer there is radiation. Now, soda lime glass is not resistant to thermal shock. All right, so soda lime glass is not resistant to thermal shock. Now, test tubes are made of Pyrex, Pyrex glass. They're made of Pyrex glass. Okay, the next question is hydrofluoric acid and phosphoric acid can attack borosilicate glasses. So, if hydrofluoric acid and phosphoric acid comes in contact with borosilicate glasses, they can actually be very, very detrimental to the state of borosilicate glasses. All right. Now, the next question is thin glassware should be used for diluting concentrated dash. All right. Thin glassware should be used for diluting concentrated acid. All right. Now, plastic laboratory materials include polystyrene, polypropylene, and polyvinyl chloride, what we know as PVC. Polyvinyl, Polyvinyl, then of course chloride. All right, so those are plastic laboratory materials. All right, now base cabinets are storage cabinets located beneath the dash top, beneath the work top. All right, so there is a part of the laboratory that is called the worktop. All right, so they are located beneath the worktop, or you can also call them workbenches. All right, so that's where base cabinets are placed. They're placed beneath them. All right, so the next one is chemical storage units are usually in the form of a wall cupboard. A wall cupboard. Now, the next one is large tools are preferred because they are easy to handle and don't occupy much space. The answer is space. All right. The next one is labs tools often come with adjustable dash for comfort. They come with adjustable height for comfort. So the stools can actually be adjusted depending on the height of the individual. All right. So it would also facilitate comfort using any laboratory equipment, and of course performing any experiments or practical in the laboratory. Now, the next question: safety goggles protects the eyes from chemical dash and irritation. They protect the eye from chemical fumes, all right, and irritation. Now, laboratory aprons are worn to protect the dash. They protect the body and clothes from chemicals. All right. The next one, latex gloves are useful in preventing direct contact between dash and the skin, direct contact between chemicals and the skin. So the answer is chemicals. All right. Then the next question there is: in a laboratory, sandals or slippers should not be worn. All right. So the reason why sandals and slippers should not be worn is that with sandals and or slippers, the skin, the foot will be exposed to any spillage. So it's best to put on shoes, to put on footwears that can cover your legs properly. All right. So number 44, a microscope is a very basic and needful dash of any laboratory, very basic and needful equipment in any laboratory. Now, the type of microscope mostly seen in schools and colleges is known as the simple light microscope. Light microscope is also called compound microscope. All right. Now, the next question is: a microscope uses light and a series of dash lenses to observe tiny specimens. So it uses light and of of course, magnifying lenses. All right, so the answer is magnifying lenses. Now, the next one, number 47: the naked eye can only see objects as small as 0.2 millimeters. All right, so you can only see objects that are small as 0.2 mm with the naked eyes, and of course any other thing that are smaller than that can only be seen using the microscope. Now, a simple microscope can magnify samples as small as 0.0002, that is 2 times 10 raised to power minus 4 mm. All right, so a simple microscope can magnify samples as small as that. Now, a microscope can magnify up to dash times depending on the lenses used, can magnify up to 1000 times depending on the lenses used. Now, the ocular lens of a microscope is also called the eyepiece. It's also called the eyepiece. All right, the part of the microscope that holds the ocular lens is called the body tube. All right, it's called the body tube. The next question here, okay, that's number 52. Okay, the rotating part of a microscope that holds objectives is called the nose piece. All right, it's called the nose piece. The platform where a specimen is placed in a microscope is the stage. Now, the dash clips are used to hold the specimen slide in place on the microscope stage. Okay, so the stage clips, they are called the stage clips. They are the clips that are used to hold the specimen slide in place to ensure that it is stable, so it doesn't move, it doesn't shake and all of that. Now, the diaphragm of a microscope regulates the amount of dash passing through the specimen. So it regulates the amount of light passing through the specimen. Okay, now the dash adjustment knob is used for rough focusing. So the coarse is spelled COARSE. So the coarse adjustment knob is used for rough focusing. Now, the next question, number 57: the dash adjustment knob is used for sharp and precise focusing, just like the opposite of the coarse. This one is called the fine adjustment knob, is used for sharp and precise focusing. All right, the next one is: the source of illumination in a microscope can be natural light or fluorescent lamps. All right, it can be natural light or fluorescent lamps. Test tubes are cylindrical pipes usually made of glass. All right, they're usually made up of glass. Now, the most common standard size of test tubes is 18 by 150 mm. So that's the standard size, 18 by 150. Now, test tubes are used for storing, mixing, and heating reagents. The answer is reagents. Test tubes are held in place during experiments by a test tube rack. So they are held in place using a test tube rack. Now, the next question, a dissecting toolkit usually contains scalpel, pins, probes, scissors, dissecting knife, slides, and of course, cover slips. Cover slips. That's the answer to number 63. All right. So, the next question, the equipment used to heat materials in the lab, often with a magnetic stirrer, is called a hot plate. It's called a hot plate. Now, the stirring action of a hot plate encourages even dash of the content. So it encourages even heating of the content, not just stirring. It also encourages the heating of the content. Now, an electronic balance is used to find the dash of a specimen. It's used to find the mass of a specimen. Dash are used to pick up small objects in the laboratory. Forceps is the answer. The forceps are used to pick up small objects in the laboratory. Now, a beaker is a cylindrical utensil made up of dash glass with a flat bottom. So a beaker is a cylindrical utensil made up of borosilicate glass. Now the spout on a beaker aids in pouring solutions. That spout, that shape that is more like the beak, the beak of a fowl. All right, so that's why it's called the beaker. All right, so it helps in pouring solutions. Okay, now the top of a beaker is usually covered with watch glasses. It's usually covered with watch glasses. Number 71. Although beakers have graduated calibrations, they are not meant for precise calculations. Even if they have um, graduated calibrations labeled on it, you cannot use them to actually make very precise, very accurate calculations. No, you cannot. All right. Now, a conical flat is also called an Erlenmeyer flat. Erlenmeyer is spelled Erlenmeyer. All right. Number 73. Okay, a conical flat has a flat bottom and a long narrow neck. All right. Number 74. Okay, a conical flask can be covered using a dash or cork, can be covered using a rubber cap or cork. Now, number 75, a conical flask should never be heated with its dash on. So a conical flask should never be heated with its cap on. All right. Now, an evaporating dish is used to dash liquids out of a substance. It's used to evaporate liquids out of substances. Okay. The next one, 77, says funnels. Funnels are used to pour substances and solutions into narrow-mouthed containers. The next question, the common types of funnels include filter, T-stool, and dropping funnels. Alright, dropping funnels. Graduated cylinders are cylindrical apparatus used for precise measurement of liquids. So the answer is measurement. The reading of a graduated cylinder must be taken at the meniscus of the liquid. Meniscus is spelled meniscus. All right, so meniscus. Now, a dropper is also known as a pasteur pipette. Pasteur is spelled pasteur, pasteur pipette. Now, number 82, droppers are used to deliver solutions dash at a time. All right, they're used to deliver solutions one drop at a time. Okay, let's move to the next question. Okay, pipettes are narrow glass pipes used to measure and so that's number 83, used to measure an exact. All right, so of course, so the exact volume of liquid. So the next one, pipettes are commonly used in titration experiment. The answer is titration. Now, a dissecting pan is used during dissection experiment in biology. Okay, Now, a specimen such as a cockroach or frog is kept. That's number. Where are we? I think. Okay, yes, we are in number 86. A specimen such as a cockroach or frog is kept on a dissecting pan during dissection. Microscope. The next one, microscope glass slides are used to support items being examined under the microscope. Next one, depression slides. Depression slides have a concavity, all right, on one surface for better support. So the answer there is concavity. Now, cover slips are used to cover specimens on glass slide to protect from dirt or chemicals. Now, cover slips also give a dash view under the microscope. So they also give a better view under the microscope. The next one, an inoculating loop is used to spread dash on a petri dish or glass slide. So it's used to spread bacteria on a petri dish or glass slide. Now, a petri dish is used to culture microorganisms. It's used to culture microorganisms. Laboratory spatulas are resistant to dash and acids. They are resistant to heat and acids. Okay. The next one, spatulas are used for handling dash in the laboratory, so they are used for handling substances and chemicals in the laboratory. Now, a thermometer is necessary to measure dash of solutions. Temperature is the answer. Now, certain biological or chemical reactions require specific temperature ranges. Okay, so a specific temperature ranges. All right, so the next one, a Bunsen burner produces a single. Okay, a Bunsen burner produces a single open flame. All right, a Bunsen burner is used for heating and sterilization purposes. All right, now litmus paper is used to determine pH, the pH of a solution. Now, filter paper helps in the process of filtration. A watch glass is round concave piece of glass. So it's a round concave piece of glass. Now, a watch glass is used to hold a small amount of liquid or solid and also to cover a beaker. All right, dyes are agents that structures of the cell. So dyes are agents that color structures of the cell. Now, stains may make usually invisible structures visible. So when you stain a particular microorganism or a particular structure, so it will make a structure that is usually invisible to be visible. Now, a common stain that turns starch blue black is known as iodine. Now, laboratory commodities are classified into four categories. Chemicals and biological agents are called reagents. Items used once and not reused are called consumables. Items that can be used for multiple tests are called the ones that are used once and not reused are called consumables. Okay, why the ones that are used for multiple tests they are called durables. All right, so number 109 is durables. Now, semi-automated or automated machines are termed equipment. The earliest simple microscope was merely a dash with a lens, so it was merely a tube with a lens. Now, a simple microscope could magnify less than dash times, so it could magnify less than 10 times. All right. Now, the first compound microscope was developed around the year 1590. Now, Zachariah Jansen and his son Hans were dash makers, so they were spectacle makers. Now, Galileo in 1609 worked out the principles of lenses. Robert Hooke improved the design of light microscope. Anton van Leeuwenhoek discovered discovered tiny living organisms in a drop of water. Now, Charles A. Spencer, an American, manufactured fine optical equipment. All right, fine optical equipment. Okay. Now, number 19, an electron microscope was co-invented by Max Knoll and Ernst Ruska. Ernst is spelled Ernst. Ruska is spelled Ruska. All right, and that was done in 1931. Okay, the earliest simple microscope was a tube with a plate for the object at one end and a dash at the other and a lens at the other. Now, the earliest simple microscope gave a magnification less than dash times the actual size. So it gave a magnification less than 10 times the actual size. Now, the simple microscope was developed by Zacharias Janssen and his son Hans Janssen. All right, Hans Janssen, that was done in 1590. Galileo, the father of modern physics and astronomy, contributed to the development of microscope in the year 1609. Now, the English father of microscopy was reconfirmed Antonio van Leeuwenhoek. Okay, the English father of microscopy who reconfirmed Anton van Leeuwenhoek discoveries was Robin Hooke. All right. 125. The American Charles A. Spencer, we've talked about him before, discovered marvelous instruments in the mid 19th century that gave magnifications up to 1250 diameter. Now, a light microscope can distinguish objects smaller than half half the wavelength of light. White light has an average length of 0.55 micrometers. Now, the electron microscope was co-invented in 1931 by Germans Max Knoll and Enstruska. We've talked about this before. Enstruska was awarded the Nobel Prize in Physics in the year 1986 for his invention of the electron microscope. Now, electron microscopes can magnify objects up to 1 million times. Now, a major limitation of electron microscope is that no Dutch specimen can survive under their high vacuum. So no living specimen can survive under their high vacuum. Now, unlike electron microscope, Dutch microscopes enable the user to see living cells in action. So unlike electron microscopes, okay, light microscopes can enable the person that is using the microscope to see living cells in action, but you cannot see living cells in action when you use electron microscope. All right, so the microscope is a scientific instrument used for magnifying and studying large objects. Okay, used for magnifying and studying very small objects. Okay, now the microscope helps scientists study microorganisms, cell, crystalline, and molecular structures. Microscopy is the science of investigating small objects and structures using a microscope. The most common type of microscope is of course, we've talked about it before, is the light microscope. 137. A microscope uses lenses to refract visible light passing through. So a dash microscope, rather, a light microscope, um, uses lenses to refract visible light passing through a thinly sectioned sample. Number 138. When light passes from one medium to another of different density, dash occurs. All right, so refraction occurs. Now, every lens has a dash index which measures how greatly a substance shows the velocity of light. So every lens has a refractive index. All right, 140. When light passes from air into the glass, it is bent. It is bent towards the normal. All right, so the next one, when light leaves glass and enters air, it is bent away from the normal. Now, a convex lens focuses parallel rays of light at a point called focal point. Now, the distance between the center of the lens and the focal point is known as the focal length. The human eyes cannot focus on objects nearer than 25 cm or 10 inches. This limitation of human eye can be overcome by using a convex lens as a simple magnifier. All right. Now, a magnifying glass provides a clear image at a much closer range. 147. The distance between the object and the lens of a microscope determines the dash. So it determines the magnification. 148. Lens strength is related to focal length. 149. The lens with a short focal length will magnify an object dash than a weaker lens with a longer focal length. So it will magnify more, to magnify an object more than a weaker lens with a longer focal length. 150, the condenser is the large light gathering. All right, called light gathering lens used to project a wide cone of light through the slide and into the objective lens. All right, so this is question 150. All right, so there are many more questions. All right, so there are many more questions. All right, that are yet to be touched. So basically, if you have gotten to 150 where we stopped, all right, so just send me a message on WhatsApp. Okay, my contact is at the top of this text. All right, at the beginning of the video, my WhatsApp contact is there. So just send me a text, all right, for so I can send you the remaining questions and of course the answers to them. All right, so also subscribe to this channel. Send a screenshot that you subscribed to this channel. All right, subscribing is for your own good, of course having to see notifications of videos when they are dropped. All right, so you can actually get access to the videos on time. Okay, so do well to subscribe and send me a screenshot that you subscribed on WhatsApp, and I will also send you the PDF of the remaining questions and the answers to them, to help you as you prepare for your exams and also to have a broader knowledge of the course. All right, thank you and bye bye.